Okay, so in this tutorial, I'm going to show you how to get your R package to pass all of the checks that you need. So in our last tutorial, we got this this KNN function in C++, and we called it using .c, and so that's okay. But now we also need to write an R function that wraps it. So let's do that. So I'm going to copy this .c code, and I'm going to make a new R script file. Save that in yes, indeed, in the R directory, and so let's call it kn.r. And so what I'm going to do is, let's try to copy that again. There we go. And so what I'm going to do is I'm going to write an R function to wrap that knn function. So let's call it knn. And so the syntax you use in R is you use this left arrow function, and you give some argument names. And so we can use the same names as we have here, x, y, let's say test x. So, you know, I usually like to give more informative names like .mat and .vec, since it clarifies about each one of the types of these things that we want. And then max neighbors. And so what we can do is, let's look at this function and let's rewrite it so that it's taking these new argument names. This is going to be x mat, this is going to be y vec, this is going to be test x vec. What else we have here? X mat, nrow x mat, and call x mat as integer max neighbors. Very good. What else we have? Okay, so then what we want to do is we want to return result list predictions from this function. And so what we need to do to write a package that passes our checks is we need to create some documentation. And to do that in RStudio, what we can do is we can do code, insert oxygen skeleton, and what we need to do is just fill out these sections. So then we can say k nearest neighbors algo, and so then we can also write some more details in this next section here. So this first line will become the title of the documentation, and then any more lines will become a description. And so a demo R function that wraps our C++ code. You know, you should write something a bit more informative than this. So document all of your arguments, input feature matrix, input label vector. Let's call this, it's also good to indicate the dimensions n by p, rather than n. Either, and you should indicate the types in your documentation as well. So numeric input label vector, numeric input feature matrix. And so it's nice to indicate either all 0, 1 for binary classification, or other real numbers for regression. Parentheses, multi-class classification not supported. So that's good to know. And then here, this would be a numeric sorry, this should be train label vector train feature matrix numeric test feature vector size p max neighbors scalar integer. So max number of neighbors, max number of neighbors. Return numeric vector of size max neighbors. Predictions from 1 to max neighbors. Right? And so the export tag here means that we want to export it, and the examples tag here means that we can write some examples. So typically, I would suggest just copying the same example that we had below, right? Or well, I mean, you need to write your own examples, but for this example, I'm gonna copy this. So if we go back in our history, here I'm going to take this example, right? And so what I'm gonna do is, again, load this data set, load zip train package equals ln stat learn, and then let's get our code again that's creating our x and y objects. So here's our x object, here's our y object. Well, actually we should use these other ones, right? We're actually doing right, it was the one we were using was I01 1 to 5, and then y is zip train I01 1 to, well, actually, you could say this is another variable, like train I. How about that? Train I. Train I. Right, and then we can use test x. Let's say that's zip train. How about, let's say test I is I01 6. And so how about we do, so our test x is going to be test I minus 1. And so then we can execute these lines of code by doing Control-Enter here. RStudio knows that even though it's in comments, you might want to run your example code. And what we can do now is we can use our function that we wrote here. We can call it like knn x, y, test x, and let's say max neighbors equals 3 like we did last time. What do we get? Could not find function knn. That's because we haven't really defined it yet, so let's define it. I just ran that code to define it. And then we get that, and then so we can compare that with our zip train test I, test I, comma 1, and so we can see that it's the same label as the k nearest neighbor model is predicting for k equals 1, 2, and 3 neighbors. So that's a nice example of how to use that function. So after having written that documentation, we can save that, and to build the documentation page, what we have to do is enable that in our build tools here, generate documentation with our oxygen. Okay. Then we can do Ctrl-shift-B to rebuild the package, and then we can see that that we should have a help page for k nearest neighbors. Right, so this is the same thing as what we just wrote in these comments. It was translated to a file here in the man directory, knn.rt, and by the build process, and so this thing is rendered in this help viewer here. And so that's one of the things that you need for a package to pass our command check. And so I'll stop the video now because it's getting a bit long, and so then I'll have another one that explains a little bit the other things that we need.